Hello everyone. It's good to be back. I hope you're all doing well. I'm going to start working on doing the videos, and this will be my first one, so we'll see how it goes. I'm going to try to keep them brief. We were asked to try to keep them around 10 minutes. I know that they've been longer, so we'll see how this works out. But today we're going to work on section 8.3, which is kind of the opposite of 8.2, where you were told a quadrilateral was a parallelogram. And then because of that, certain properties applied. Today we're going to actually show that a quadrilateral is a parallelogram without knowing that both pairs of opposite sides are parallel. So these are kind of our learning target for today, and this is the kinds of things that you should be able to do once we've gone through the lesson and you've done the homework problems. So recall from yesterday that we talked, Mr. Oslin actually talked about how the definition of a parallelogram was the fact that both pairs of opposite sides are parallel. That's what it means to be a parallelogram. And once we have determined that, yes, indeed, it is a parallelogram, then there's a whole bunch of other things that we can say. That is, opposite sides are congruent, its opposite angles are congruent, and the consecutive angles would be supplementary, which means they add up to 180, and the diagonals bisect each other. So if you didn't get very good notes from this yesterday, you may just want to pause the video right now and review those things. But today we're going to see if we can show that something is a parallelogram, prove it, if we don't know that opposite sides are parallel. So here's an example. Can we prove that this is a parallelogram if all we're given is that BD and AC bisect each other? Well, that's already marked in this diagram, and so if we start this proof, I can see that both of those sides are congruent. That's what bisect means. And I can also see that AE and EC are congruent. So actually that's really the first step that we would do, is we would simply state then that BE is congruent to DE and that AE is congruent to CE. And that would just be simply by definition of bisector. Okay, so now that we know that, okay, we also know that angle E, or actually angle BEC, is going to be congruent to angle AED. So why do I want to know that? Because now I can prove those two triangles are congruent. So first I need to state that angle BEC is congruent to angle DEA. And that would be due to vertical angles. Okay, well, now what I know then is that this triangle right here, whoops, I did not want to use that color, use a little different color. This triangle and this triangle are congruent because we have side angle side. So the next thing I can state then is that the two triangles are congruent. So triangle BEC is congruent to triangle DEA, and we know that because of our side angle side congruence theorem. So why did we need to prove those triangles were congruent? Because now what we can show is we can show that this angle right here and this angle right here are congruent with CPCTC. So I'll go ahead and write that angle CBE is congruent to angle ADE, and that is because of CPCTC. Well, when you look at these lines right here, BC and AD, and you extend them, and then you have this transversal right here, you have parallel lines cut by a transversal. well, you actually don't know they're parallel, but because those angles are congruent, that means the lines are parallel. That's the converse of the alternate interior angles theorem. So now I've just proven that side BC is parallel to side DA because of the alternate interior angles converse. Because if those angles are congruent, if alternate interior angles are congruent, then the lines are parallel. So I've now shown that this line right here is parallel to this line right here. That's half of a parallelogram. That's half of what the definition of parallelogram is. But now what I also need to do is I need to be able to show that these two lines are also parallel. Well, all I need to do to show that is kind of go to the same thing and show that these two triangles are congruent. And I already know the sides are congruent to those two triangles. That was given. So all I need to do now is do a vertical angle again. So now if I say that angle BEA is congruent to angle DEA because of vertical angles, now I can also show then those triangles are congruent with because of side angle side. So now I can say that triangle BEA is congruent to triangle DEA. And because of CPCTC now, I can also show that now we have these lines right here. I don't know why it doesn't want to give me my colors here. I have these lines right here now and cut by this transversal right here. And I just proved these two triangles were congruent. So now if I mark this angle and this angle, I also have, I also have the converse of the alternate interior angles, which shows that these two sides are also parallel, which means it's a parallelogram. So all I have left to do, I've proved the triangles are congruent. So now I need to just state the two alternate interior angles that are congruent. So angle BAE is congruent to angle DCE. And again, that is by CPCTC, which now gives me the fact that because of those two angles are congruent by the alternate interior angles converse, then I know that side BA is parallel to side DC, which means that ABCD is a parallelogram. And that is by definition of parallelogram. Now I know you did some proofs with Mr. Oslin also in the lesson, and so this is just sort of another type of proof that's actually showing that we can prove that this quadrilateral is a parallelogram without knowing that anything about parallel sides. Now that was a pretty rigorous proof. That one was a lot more involved. There are other proofs that we could do, but because of time, I'm just going to kind of walk you through this one. This is going to be a pretty simple proof because I'm given these pieces of information right here. I'm given that this side is parallel and congruent to this side, parallel congruent. And because of this transversal right here and parallel lines, it gives me these alternate interior angles are congruent. Here's the difference. I knew that those lines were parallel, so now I can say alternate interior angles are congruent. So now I would be able to prove that the triangles are congruent with side angle side because I have this reflexive side in each triangle. And now once I have these two triangles are congruent, then I will also be able to show that these lines right here I'll be able to show additional angles right here are congruent. These alternate interior angles right here, get a different color here. This alternate interior angle and this alternate interior angle would prove that, so through CPCTC, I can get those angles that are congruent. And then, because those angles are congruent, the alternate interior angles converse would give me that then these two sides are also parallel, so it's a parallelogram. Now that was a pretty walk-through kind of style proof. We didn't actually write it in a 2-column format, but again, I'm trying to be conscious of the length of the videos. I have one other proof here. If you want to try it on your own, there is an answer to it or a proof of it, more of a paragraph style, on page 522. But all of this is really leading, okay, to the fact that the theorems or the ideas from a parallelogram, the converse of those theorems that you learned yesterday are also true. So that now we can say that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, so both pairs of opposite side, that's all we need to know. And we can say then it's a parallelogram. And once we say it's a parallelogram, all the other properties apply. Okay, we can also do the same thing if we just know that both pairs of opposite angles are congruent. So I have these pairs are congruent, then that's enough to show that it is a parallelogram. The last two, one of them we already kind of walked through these two proofs, okay, together. But if one pair of opposite sides are congruent and parallel, so if you have just one pair, but they're both parallel and congruent, that would also be enough to prove that that is a parallelogram. And finally, the first kind of more involved proof that we did is if the diagonals bisect each other, then it's a parallelogram. So if we can see that these diagonals bisect each other, then it is a parallelogram. So again, these are all just kind of ways to prove that a quadrilateral is a parallelogram. And this is kind of a summary of all the things that we sort of have covered so far. So this might be a good time to pause the video and put this down in your notes, or at least make a note to go back and refer to this. So moving forward a little bit and just kind of applying the information that we had, it says draw a figure with the same properties that is clearly not a parallelogram. Well, all we're given here is that these two sides are congruent. So I can have two congruent sides like this, but have them more offset. So I guess I should maybe shorten this on this side a little bit and have them offset like this. But then this side right here does not necessarily have to be the same length. So these two sides can still be the same, but these would not. And the same is true for this one. We could actually have parallel lines right here, but they're different lengths. And so we could have more of a trapezoid rather than a parallelogram. So let's try to see if we can say these are parallelograms. Well, what do we know on this one? Well, we know that these opposite sides are both congruent and parallel. So yes, this is a parallelogram. Over here, we have both pairs of opposite sides are congruent. So yes, that was one of our shortcuts of proving a parallelogram. Opposite angles here are congruent. So yes, parallelogram. All of those are parallelograms. So now when we get to this bottom one, it says, for what value of x is a quadrilateral the parallelogram? So in other words, right now, we don't know if this is a parallelogram or not. But we do know that if these diagonals will bisect each other, then it will be a parallelogram. So I see that these two are the same right here. So this and this are congruent. So as long as these two would be congruent, it would be a parallelogram. So all I have to do is make that happen and find out what value of x would make that true. And if we quickly solve this, we would get the value of x is equal to 2. So some of these can get kind of tricky because sometimes you're looking at this and you're like, can we say if this is a parallelogram or not? Well, in this first one, we have a pair of parallel sides right here, but we don't have the same, aren't the same parallel sides that are congruent. So in this case, no, okay? We cannot prove it that this is a parallelogram, okay? Over here, now we have this pair of opposite sides are congruent and this pair of opposite sides are congruent. So yes, it just so happens that both pairs of opposite sides happen to be the same. They're not only congruent, but they're all for the same measure. That still meets one of those theorems, converse theorems. This one gets kind of tricky because we have parallel, okay? We have opposite angles, but there's no theorem or converse theorem that says that that's enough to prove a parallelogram. But remember, when we have these parallel lines, okay, cut by these transversals right here, here's a transversal. Here's a transversal. Now this is kind of tricky, but if you look at this a little closer, we know that from our parallel lines theorems that this angle right here has to be supplementary to this angle right here. Well, if these two angles are the same, then this angle will also have to be supplementary to this, and since they're both the same, then those two supplementary angles would also be the same. So now we actually can say yes, because what we have here is we have both pairs of opposite angles are congruent. And last but not least, we do not have enough information here to say anything. We have one pair of congruent sides, we don't have another one, and we don't have anything parallel where we can get any other angles or sides. So this one is no. So those are some of the things that you're going to try to decipher in your homework and try to make sense of. The last question I want to talk about is more of a kind of a coordinate proof problem or coordinate problem. So it says show that quadrilateral ABCD is a parallelogram. Well, I took the time to already graph this, so I plotted all those points. Well, it looks like a parallelogram, but that's not enough to say that it's a parallelogram. So here's a couple options, okay? One thing we could do is we could show, if we could show that AB was congruent to DC and that AD was congruent to BC, then that would be enough to show that they're parallel. In order to do that, I would use the distance formula using those ordered pairs to find that out. But there's another thing we could do as well that might actually be simpler. What we could do is if we could show, which would probably be easier, if we could show that AB was parallel to DC and that AD was parallel to BC, that would be enough to prove, because then we'd have both pairs of opposite sides are parallel, and that by definition is a parallelogram. So now all we have to do is find the slopes of each one. And there actually is another thing that would be pretty simple, that wouldn't be too bad, whoops, and that would be, we could actually show that like AB was parallel to DC using their slopes, and that AB was congruent to DC by using the distance formula. And so I'm not going to walk through actually doing all of that on this video, but I will post the answers to all of those worked out on the lesson notes when I post this. So that's kind of a walkthrough of a lot of the ideas and information. You'll find your assignment for today. I'm trying to set it up similar to the way Mr. Oslin did the first two in this lesson, and then I'm going to kind of collect some information from you to see how this is going versus just assigning problems of the book and having you submit electronically that way. So Again, take advantage of my office hours and email me questions. Right now, we're not able to do any video conferencing through Zoom or Google Meets or Hangout or anything. The district has asked us to stop us doing that for this week. So maybe we can start that up again. We'll just have to wait and see. Have a great day.